so it's going to change based on the window. Okay, so we're still using that same problem, but if you look at your problem number 7 now, it's asking you a question based on that regression that you've just come up with. And it says here, the regression equation is approximately, and they gave you this approximate equation, and that's exactly what we've already put into the calculator. Okay, they rounded it to the second decimal place. And so for these, you do need to still write your regression equation. Okay, are we good with that? Do you know how to get that? Okay, so if we move on to question number 13, it's still using that same problem number 1, that same regression that we've just come up with. So there's 3 steps to this. One is coming up with what you think, what kind of regression you think it's going to be. The second is actually determining what that regression calculation would be. And then the third part is solving a question based on that regression. Okay, so Charlotte wants to make sure the hot chocolate is not too hot for her daughter. She wants to pour the water at about 60 degrees Celsius. Use the regression equation for problem 1 to predict after how many minutes she should pour the water from the kettle. Okay, what are we looking for? Are we looking for our input or are we looking for the output? We're looking for the input. Remember, our input was time and our output was temperature. Okay, so when we're looking for the input, when you're looking for the input, use intersection feature. Okay, we're given what our second y is equal. We want to know when is this going to equal 60 degrees Celsius. Okay, so our first equation, which is already in our calculator, is the regression equation. This is going to be your regression. Your y2 is 60. So you want to know what your x value is at that intersection point when it hits 60 degrees Celsius. Okay, that's what you're looking for. So go to your calculator and put in y2, put 60. In the y2, put 60. And now graph it. It was probably recording that. Okay, so how do you find intersection? So once you have your y1, which is your regression calculation, and y2 was our 60, you find the intersection. And you find the intersection by going second, isn't it second trace, which gets you to calc?
Yeah.
Okay, so second trace, which gets you to calc, and then you go number 5 for intersection. Okay, so right now we've got a parabola and a line, and we want to know what these intersection points are. Okay, so when you do this, you get y1. Your screen will say y1, and it'll give you that regression equation that the top left of your screen. That's what it says, right? And then once you hit enter, you'll hit y2, and that'll give you 60, and you're going to hit enter again, and you see the word guess. And do I care about your guesses? No. I don't. Hit enter again, and then you see the word intersection. And we are looking for the x value, right? We know what the y value is. We know it's 60. So what's our x value here? This is 10.8. And what is this one?
48.
48 point something, right? 4? It doesn't matter. So what does this mean? This means if you rounded it to the nearest minute, this means at 11 minutes, that hot chocolate would be ready according to this graph, and then at 48 minutes. Okay, if we were using this regression calculation. Is this a good fit?
Yeah.
No, it's a bad fit. How do I know it's bad?
It's not going to be the same.
Because my R2 value is 0.75. What do we want our R2 values to be?
1.
Close to 1. Okay? Okay? Are we good? Yes? Great.